Let's talk about the promise of promises in JavaScript, or trying to think synchronously in an asynchronous language. It's kind of a backdrop. Let's return back to our conceptual discussion of this kind of new model. We had talked about multi-process ways of web development. We had talked about multi-threaded ways with the component container model and things like that. But now we're talking about Node.js increasing scalability through high throughput, hamster on a treadmill, um, churning through the work that we give it across multiple HTTP requests. And that actually scales better because we don't have all the context switching that goes on. We're actually maintaining multiple logical concurrent processing, I don't want to say threads, but lines of work, tasks associated with each request, by putting that work on the event loop and having the event loop churn as fast as it can. Now, that means that blocking requests are bad. We're doing this in an asynchronous world, so we don't want to block. We don't want to hold up the event loop and hold up the processor, not do anything to wait for a result. So our calls tend to be asynchronous. And we try and get rid of those blocking invocations. That single-threaded, non-blocking use of callbacks that created a number of pros and cons. The pros were we didn't have to worry about in a multi-threading model doing things like synchronized blocks. We had a very efficient event loop as long as we were giving it nice, discrete, small computational tasks, meaning we kind of chunked up our work appropriately. We were very efficient, and we didn't have that context switch. We didn't have the overhead about switching between threads, even in a lightweight world, and certainly not switching between processes, a heavy resource from the operating system perspective. So we've talked about all that. But some of the cons, and that's what we want to talk about today. It's an awkward coding model at first, and frankly, maybe forever. It can be difficult to get used to reading asynchronous code and reading with embedded callbacks. Threads are natural extensions of a process, so we can conceptually think about the parallel, the inherent, the concurrent nature. We think of it as parallel. It's not really parallel, right? We have multiple logical tasks going on again, multiple requests for handling at once. And no matter which architecture we're doing it, we want to conceptually understand those things as distinct and independent, and that can be difficult in this single-threaded model. And again, not natural to object orientation. It's hard to think of an encapsulated call sequence when you're working in this world. But we're going to talk mostly about the awkward coding model and the this kind of extension thing. In fact, this is a different diagram that I've shown in your reading over here on the right that talks about, what it's really like over time. If you're looking at, and let me get out my pen again, if we're looking down in time this way, if that's time, right? Each of these is an incoming set of requests, a connection into our Node HTTP server. These blocks represent the amount of work, the amount of time spent in the event loop processing. And again, we like smaller, discrete ones than things that are larger and taking up more of the cycles, because again, there's no such true thing as parallelism, right? There's no two things that happen at once when you're talking about a logically single CPU architecture. There are things that are logically concurrent, right? This whole block, right? This whole thing is logically concurrent because all 10 requests are in some stage of processing at some point. They're going on at the same time, right? In terms of space, they are executing it at the same time in some neighborhood of time. All right, but they're not truly in parallel. It's this event loop churning through and doing this work. All right, so we have this non-determinism going on, meaning if I gave those same 10 requests again, there's no guarantee that they'd wind up getting processed according to this particular ordering, if you will. So we don't know which one comes out first, second, or third. Now, that's fine with respect to these logically different requests. But what happens if we're in a single processing request and we're doing things like reading files or whatnot asynchronously, and we're trying to get a sense of ordering around things, all right? And that's what the top part of the slides are about. We have these wonderful asynchronous, non-blocking, high throughput behaviors in JavaScript, but are we having fun yet? Well, no, we're not really having a lot of fun because, our brains are used to a traditional coding experience. Our brains are used to reading code top down. Just like we are the CPU, we like to mentally trace through code top down and think of the state of our variables, and it works in an almost very line by line transactionally oriented way. But when we're asynchronous and we have functional code like JavaScript, you can't really read it top to bottom. You read declarations starting top to bottom, but then there's a callback, typically embedded in the middle somewhere. And that's not invoked right away. It's declared, and then it's bound based on some system event, usually that comes back in, let's say from file IO being done. So we're looking kind of back upwards in our code, trying to find the callback that's being executed at some particular point in time when something goes on, and it can be very difficult to trace through. To read mentally when the code editor is open, as well as trying to understand the non-deterministic nature of asynchronous processing, because again, an overlapping set of requests, I never know exactly how this layout's going to wind up being. Okay, so it's hard. It's hard to read this code. It can be confusing. Promises are one mechanism to try and help us with that. They try and help with the verbosity of the callback model, and they try and help. I mean, they can't really get rid of non-determinism fully, but they give you a sense of being able to read the code synchronously and trace it and understand the order and control the order in a sense of what things are happening when. So what is a promise itself? In JavaScript, a promise represents the eventual result of an asynchronous operation. The eventual result, right? We already have that with callbacks, right? We bind a callback typically as the last parameter to an asynchronous function. That's going to get invoked when that asynchronous function completes execution based on its result. All right, but a promise is an object that represents, it kind of wraps, if you will, that eventual result, and indicates and does different things based on whether it's successful or not. What's called in promise land resolved or rejected. Okay, when you're creating a promise, so you can use libraries that return promise objects, or you can create your own promise object. So you're going to create your own promise object, then it's an object, so you just call new on it, and you can bind it to your own variable. And in your declaration, you have to indicate the resolve part and the reject part, and we'll talk about that. The resolve and reject definitions are essentially different operations. They can take parameters. It has that function-like syntax that we're used to, but it doesn't look as the same, as you'll see shortly when you use it, as the array or nesting of callbacks that we've seen before. For your own thing, if you have your own asynchronous function, you probably usually want to wrap a promise around it. One of the things that's I'll get to it, but one of the drawbacks of promises is it can tend to be intrusive. You have to write extra code around your code if you want to create a custom promise in order to wrap those things around asynchronous functions. However, because promises are now part of the standard, more and more libraries are simply indicating that there's a compatibility with using promises, and you can be aware if it returns a promise to you. So you only have to play the caller, right? This syntax is if you're creating your own, and what I'm saying is you don't often have to create your own, but you certainly can. The caller of a function that returns, so if you're the caller, which is typically what you're going to do, then usually what you're going to do is just call then. There's a few different predicates on here. I really don't want to go into all of them. Promise does have its own API. The main thing you're going to do is call then, and with then you're going to have whether or not the promise was fulfilled, or in this case resolved, or whether it was rejected and there was some kind of error. So it's essentially a kind of a conditional block, if you will, an either or block that says when the promise is resolved, if that resolution was that the promise was fulfilled, then I'll invoke something. Otherwise, if it's rejected, I'll invoke something else. All right. One thing about a promise, the onFulfilled and onReject functions, when those things are declared inside of then, they can only be called once. In fact, promises in general are immutable. Once you take a promise object and resolve or reject it, then you can't reuse the same object instance again. The declaration you can use over and over, but you got to keep reinstantiating a new object, as we'll see. Here's a simple promise example. At the top, I have an example. This is in your GitHub. I have an example of the traditional callback hell, as we called it, right? This nested structure. What is this? This is your file folders example that was in your node intro folder. I shortened it. I took in just the make dir part of it. And notice this whole slanting part. Why is it slanted? Because I'm calling the make directory out of the file system, asynchronous make directory. Now I want to control. I want to be able to create a data subdirectory followed by a data with folder A, followed by a data with folder B, a data with folder D under that. All right, so I'm creating a 4-level deep subdirectory structure using the FS module's make directory call. But in order to sequence that, right, I can't create this one down here without creating the one above it, because this relies on that already being in existence, which means I've got to chain them, right? And in order to chain them, I have to nest the callbacks. A traditional way to sequence things or to chain calls means I have to chain the callback. So here I have the callback for the top level call, right, from here down through here, and in here I got to check for errors, right? My first parameter is always going to be the error. I got to check and see whether or not that worked or not, and if it did, I'll be in the else block, and then I can make the next call, and then I got to go through the same sequence and make the next nested call here, and then I got to go down and make the last nested call in order to get all the way down here, where in the final else one I know I made all directories, right? That's what that this example runs. I'm in a directory. I'll do node file folders short. All right, all directories made. If I do an ls-lr recursive directory listing of the data subdirectory, there you go. I have the data directory with folder A. Underneath folder A, I have underneath folder A, I have folder B, and underneath folder B, I have folder D. So successfully made all these directories. So, that works, all right? There's no particular problem getting that working. And again, over time, you get more and more used to seeing this callback hell with this, wild nested stuff going on. However, this is still verbose. There's still multiple layers of error handling at each one. The indentation makes it hard to read, and trying to pick out the key parts of this, the different make directory calls, is difficult, right? Scanning and reading this code top down and understanding it is non-trivial, even for a trivial example like this. Whereas compared to the example down here using promises. In this case, we're taking and creating a function makedir that wraps the makedir call here, and what it's going to return, my function makedir is going to return a new promise. All right, so this is the first line. This is all the function does, and there's the embedded function resolve reject. I didn't use the arrow syntax here. I used the embedded function declaration syntax. So this function, goes down is this part right here, and it goes ahead and makes the make directory call, and the make directory call itself remains asynchronous, right? This generally is the same as any of the calls up here. The only difference is I'm passing in the directory I want to create as a parameter. Okay, once I have that, then I can go ahead with returning a promise I can invoke then. So I can call my makedir on data. I'm returning a promise object. All right, I'm returning one of these guys. I have an instance here, so I can call .then on it, and then I have my onFulfilled. In this case, I'm not returning, I'm only returning a promise object, no data with it or anything else. So here I am using the arrow syntax, and I'm basically saying what I want to do in the onFulfilled successful case is then turn around and make another make directory call, now the subdirectory. And if that's successful, I'm going to make another one. If that's successful, I'm going to make another one until finally I'm done with all those. Or if any case I have a catch of any error that's returned, because if I have an error on the reject case, then I'm fine. Notice up here, and I know I'm scribbling over things that makes it hard to see again. But notice how I indicate on my resolve reject, what I'm returning, whether I'm returning with an error that I had to reject, in which case the reject is actually returning the error, which means I can catch it with error here. But here I'm just doing the resolve, but that's why that's an empty paren. Okay, but the real point is here, again, first time looking at a promise, even this syntax looks different because you haven't seen this kind of chained call with a then on it before, specific to promises. But at the same time, look at how much shorter this is compared to this. Look at how we don't have callback hell with embedded nested callbacks. The nesting here is a straight sequential like structure, right? It reads like synchronous codes, even with the natural language dialect of putting a then there, saying, okay, I make directory data, I'm successful, then I'll make a directory with folder A, then I'll make a directory with folder B, then I'll make a directory with folder B, and if I ever have an error, I'll output that there's an error. That's it, right? That's That's a lot shorter and more readable than the one up top. So, of course, this one runs successfully. Let me get back to my window. I removed that, so let me run the one with the promise. Okay, that one did now put a statement at the end, but if I go look, I will once again have the same set of directories. Now, what happens in the error case? Well, what happens in the error case? In this case, I'm running it again. I didn't remove the directory, so I have an error, right? But this is telling me what the error is. I'm actually outputting. This encountered error with the error case down here, right, is the one you see down at the bottom of the slide at the bottom of the screen here. It says encountered error in the error2 string. So this part was the error actually returned by the file system module's error call. Okay, so again, of course, it's going to take a little bit getting used to, but once you get used to it, you can see the avoidance of callback hell and the ability to read this almost in a synchronous way compared to the asynchronous callbacks is one of the big benefits of promises. A lot of it, I mean, really under the scene, the same kind of things going on, I guess saying. It's the readability of it that lays to that kind of maintenance. And we'll talk about a more complicated example in a code walkthrough, but that ability to kind of keep code together in a more encapsulated way, keep what you're doing together as opposed to distributed. What I mean by that, look simply at the error cases up top here. All these error cases are distributed throughout the code. I mean, it makes it harder to read through each individual nesting one, and that specific order means I have to kind of have an implied notion of state running through that. Okay. More about promises. The .then calls can be chained. In fact, the previous example did chain them, right? That's if your promise function returns a promise. In this case, we were using the same factored function that we created, so our promise did return a promise, but that doesn't always have to be the case. When creating a promise object with new, that wrapped function is executed immediately. So when we did the new promise call inside of makedir, as soon as we did it, it doesn't defer execution just because you're newing up the object. It's going to invoke that fs.makedir right away of that first one. Some folks don't like that. Some folks they would like to defer execution based on the state of the object, but that's not how it works. At any point in time, so a promise object itself is in one of three states. So just like all objects, it's stateful. It's in one of three states: the state of fulfilled, rejected, or pending. Okay, if it's fulfilled or rejected, then we call it settled, right? But settled, I mean, settled is just a fancy word. You can read it out there in Node World. All we're saying is we have an initial state. You've done plenty of state charts before. We are pending on the promise, and then we're either fulfilled, which is a final state, or we are rejected, which is a final state. That's all it's saying. If you're either one of these, then you're called settled. That's all that means. All right, fancy words for things that you already know. And what that means, notice it's a final state and there's no outgoing transitions. That means it's immutable. Once that promise object has been fulfilled or rejected, it's immutable, and that's why you can't reuse that promise object and re-execute any of the embedded functions that are in them. There's some additional features I'm not going to go into here that you can look up. You might wonder if there's some convenience. Yes, there's a promise.race that takes an iterable like an array and a return a promise itself that resolves with the value of the first promise that resolves in the iterable, else it rejects. So the race basically will fire off all these things and will resolve as soon as the first one in that iterable resolves. And then there's a promise.all, which does well, not exactly the opposite, but the converse. Takes an iterable and returns a promise that resolves when all, not just the first of the promises in the iterable, have resolved, or rejects when the first promise rejects. So that's a way, if you're bundling work together and you kind of have this almost activity diagram kind of pseudo parallelism going on, and you want one point where you know all they are, this would be, an all. And if you're looking for any just one of those to be done, then you could use a race. All is probably far more common than race in my experience. But these kind of they're really just kind of convenience things. You could do a similar thing the long way through a chain, for example. But these things again help shorten the syntax, shorten the verbosity, and avoid common code idioms by just rolling them into a convenience that they've already created for you. Okay. So that's promises, a summary. Promise can help us at least start to get out of callback hell. I mean, we still kind of have this, this isn't necessarily the easiest and I'm talking about down here. This isn't necessarily the easiest thing to read either, but certainly would argue it's a lot better than this up here. So we at least start to get at a callback hell. It gives us this pseudo-synchronous feel in the way we write the asynchronous code, and certainly the way we read it and understand it. It can reduce that verbosity, as we've seen, and keep behaviors together, like I was talking about. There's some cons. I mean, it's a little bit of a performance hit. As I mentioned, there's some overhead to it, meaning, and it is a little bit intrusive, meaning if you're writing your own promises and you have to wrap code to introduce a promise, that's some of the things you have to do. ECMA 6 added built-in support for promises, so now it's come along. I believe it was Node 8. By the way, I mentioned ECMA 6 as opposed to Node. I say it here. They're an ECMA standard, which means their use is not specific to Node. And again, I'm pretty sure it was Node 8 that introduced promises. But any JavaScript environment that conforms to ECMA 6 or later is going to have built-in support for promises. So if you go out and read about promises on the internet, you might read about third-party libraries like jQuery or Q, which is normally lowercase q, providing promise behaviors, promise-like behaviors. You can read about polyfills, as they're called, and things that will try and provide this functionality to libraries that don't have it. Well, now not that everybody's gotten converted their libraries over to promises, but now that they're part of the standard, you're starting to see that more and more. That folks are starting to use promises more and more in what they're doing. And again, noting that it's an ECMA 6, because that means we'll also see their use in browsers. In fact, some of the use cases for browser-side programming and promises might even be more compelling than what you see on the Node side. All right, so we will see them again. So that's a real brief overview to promises. There's also a companion code walkthrough that goes through a bit of a longer example for promises.